Alright, so we're going to do a video on using 3D constraints to animate things. So the whole idea of this one's to allow you to kind of make mechanisms in Inventor, like levers and gears and things, and just make things move so you can test out whether they'd work. Right, this will be particularly useful for the engineers, but the electronics guys might need it for some parts in their boxes. But anyway, let's have a go. So I'd like you to, when you start Inventor, click Home if you need to get back to this screen and make yourself a new project. So go out to Project, New One, Single User, and let's call it Mechanism, anything like that. Alright, we'll just click OK, go through all that, click Done. Alright, as always we start with an assembly, and I'm just going to kind of make this up as I go along really, so I haven't got the sizes written down anywhere for any of the bits, but we're going to start by saving our assembly, call that the whole mechanism, and then we are going to create our first part. So I'm going to call this the backboard. Alright, and what we're going to make today is a kind of model of a crankshaft mechanism, a bit like what makes a car engine work, as in a piston that moves up and down, so it turns reciprocating motion into rotary motion. So we've made our part, we're going to start with a sketch and just follow my lead on the dimensions. So let's go with a simple rectangle. I'm going to make it, I don't know, 100 by 100, easy. I'm going to get a circle, and I'm going to make a circle here, maybe. Let's put it in line with the middle, and I'm going to go, I don't know, 8mm. I'm going to put a dimension on the circle, and maybe make it about 25 from the bottom. I'm just guessing at the moment. And finish the sketch. Okay, I'm going to extrude that lot. I don't know, 10mm sounds good. And I'm going to add some new bits onto it now. So I'm going to start another sketch on it. I'm going to draw myself a rectangular box, and I'm going to go 50 by 50, and I'm going to get this tool here, collinear, so I can click that, so that's this tool, so select that and the top edge, that'll make them line up, and then I'm going to put a dimension from here to here and make that 25, so this is kind of spaced in the middle. Alright, what I'm then going to do is put, I'm just going to draw another rectangle over that, so I'm just freeforming this. I'm going to make it, let's go 5 thick, and then another rectangle in this corner. You'll see where this is all going in a minute. Finish the sketch. I'm going to extrude that bit and that bit, but make sure they go in the other direction by clicking this arrow. Actually no, sorry, I do tell a lie. I want you to come back this way, and let's come out like, I don't know, 30, something like that. Alright, this is just a test place to show you the idea, alright, so obviously I can see this wouldn't be a very good product, so I'm done with that for now. Click return. What we're going to do now, we're going to create our piston. Now, you might remember our gap here was 50, 50. But these were 5mm thick each, so 50 minus 5 and minus 5 gives us 40. So our piston's got to be 40 wide to fit in here, and we made it about 30 deep this way, and then about 50 tall. Okay, so I'm going to create a brand new part. I'm going to call it piston. I'm going to click Start Sketch. Sorry I'm going a bit faster, but you should be used to that by now. And I'm going to draw a rectangle that measures 40 horizontally by, let's say, 50 tall. Okay, finish it. In fact, actually no, I'm going to add one other thing to it, sorry, before I do that. I'm going to make another circle on this guy. I'm going to make a 8mm circle, and I'm going to put a dimension on it. Sorry, try that again. I'm going to dimension it 8mm from the bottom and 20 from the side, which it already is, so it's dead in the middle, and 8 from the bottom. Finish that. The depth of this was 30, so I'm going to extrude that whole lot by 30. And just to make it stand out a bit more, while I'm at it, I'm going to go and choose a different colour. from my material list. Let's go with black. Okay, right, I'm done with this part, so I'm going to click return. Right, now we're going to start looking at using constraints to make stuff move. So I want my piston to sit inside these little guide rails here. I'm going to use the constraint tool, and all I'm going to do for now is I'm going to constrain the front panel of this to the back of that. And that was using the mate constraint, so click apply. That's now stuck and can slide all around the face. And I'm going to constrain this to here. Now what you'll see is what I've made allows me to slide that up and down. Okay, so I've got the startings of a piston. What we're going to make now is the disc and a connecting rod and make them all move each other. Okay, right, what we'll do now, we're going to create. I'm going to call this the crankshaft. That's the best way of describing it. I'm going to click anywhere and I'm going to start sketch, and I'm going to draw an 8mm circle, and then I'm going to draw, I'm actually going to show you this differently so you can see another tool. I'm going to draw myself, let's go with an 80 diameter disc, but I want these two on the same axis. Now I could have drawn them together, but I'm going to line them up by showing you another tool, which is this guy here, concentric. So I'm going to click that, click and click, and that's put them on top of each other. Okay, finish this guy. I'm going to extrude this by 30 as well. I'm going to make it a completely different colour again, gold, and I'm going to click return. And now I'm going to use another constraint, so I'm going to click constrain, and this time I want to constrain this to the back of the disc, so it's now touching it. And now I want the two holes to line up, so we are going to, still with mate selected, hover, we don't want that, but we want that, so you get this sort of dotted line down the middle. That's the axis, so we're going to click that and do the same arrangement on here, not the circle but the circle with the dotted line, and you'll see that has aligned both axes. Alright, so now we've strapped our wheel and we've strapped our piston, but what I want to be able to do is to turn this and make that move up and down like a real piston would. Okay, right, we need to put a hole in this guy, so I'm going to click on there. So I'm working back on my part again. I'm going to make another sketch on it, and it doesn't matter if the view's different, but draw yourself another circle. Doesn't actually really matter where, but roughly about where I've got it. I'm going to go 8mm big, and I'm going to put a dimension from the centre of, what, I don't know, let's do 30. Okay, and click finish, and I'm going to click extrude, pick the bit I want to extrude, which is that, as a cut this time, all the way through, click OK, and return. So now I've got a disc with that running round and round and round. Okay, final job. What I want to do is if you imagine that's as far as I want my piston to come down, and that's as far as the circle would ever reach, I'm going to figure out how far it is between these 2 points. So I'm going to go inspect, distance, and I'm going to click so the cylinder appears and the cylinder appears, and that blue line has measured it and says up here it's about 77mm. So I'm going to make a new part now with 2 holes spaced about 77 apart. So go back to assemble, create, and I'm going to call this this would be the con rod, the connecting rod, that's what they'd call it in the engine. I'm going to click anywhere to draw it. I'm going to start a sketch. And what I'm going to do here is I'm going to get a circle tool, make an 8mm circle. I'm going to draw another circle up here somewhere, get a dimension, and between the centre of that one and the centre of this one, I want to be about 78, because that's what I made, that distance, when I measured it. Right, I want to encase that in something now, so there's a clever tool for that called, if I can find it, here we go, under rectangle, click the arrow, it's called slot. So I believe you can just click from that point to this point. Actually I did that wrong, let's try it again. So I'm going to start here, a little bit higher, a little bit further there, and draw that. Okay, and then all I'm going to do, because I like being neat, I'm going to do a dimension between here and here of 0, and here and here. It's the 2 dots if you can't see it. of 0. Alright, I'm going to put a dimension from here to here. That will allow me to choose the width of it. Let's go 20, so it's not excessively big. Finish it, extrude it. Let's make this only, well, I'll leave it at 10. Okay, and return. Now we've made our connecting rod. All that's left to do is join them together. So C for constrain, or click constrain. First thing is to join the disc to the back of it, so it's lying on the surface, but it's obviously not connected to it other than in contact with it. And now we're going to use constrain again, and using the axis of that, we're going to line up with the axis of this. I really hope this works. I've not tried it out yet. You might have to then move it out of the way slightly. Can you see where we're going with this? Look, it already drags it. Now I'm going to get constrain and choose that and this hole. Click apply. Now in theory I should be able to turn this, and as you can see, Inventor simulates this like a real mechanism. Alright, and that is how to use constraints to make things move. Okay. Now I just want to show you something that's very clever at the moment. If I was to change this part, alright, so let's click it and go back to the sketch over here and make this number longer, let's say 100. That will grow, click finish sketch. That will grow, click return, therefore the distance has grown. So I could modify and change my mechanism as I go. So this is what an engineer would do when designing a car engine until they got everything moving in the right amount of directions. I should actually be able to push and pull on the rod as well, but it doesn't work quite as well as if you turn in the crank. Or I could do this. Let's go in and make it shorter than 78. So go change the sketch. Let's actually make it 60. Now what you'll see here, if I return, we've got a collision. We can clearly see, look, that collides. Yet Inventor allows us to do it anyway. There is a way of detecting collisions and Inventor actually stopping and jamming like it would do in real life if you want to simulate that. The way you do it is the parts that you know might collide, you select them, you right click on them, and you activate this thing called contact set by ticking it or selecting it. So I've done it on the block. I know it might collide with a gold thing, so select the gold thing, right click, select contact set, and then you go up to inspect, activate contact solver. Now if you gently turn this, when they come together, you will find at the point that they jam. Okay, so it's a really powerful tool if you're trying to design mechanisms or moving parts, so as the engineers would be. Alright, so I hope this has been useful to some of you. What I'd like you to do from then on really is just experiment and explore. Build, test out more constraints. You can do all sorts with this program. Alright, thank you.